Hello, friends. This is my 57th stream. So, today I'm going to be looking at transport layer security, which I've been looking at for the last, 5 streams. And we're going to introduce certificates. So, I've been working on basically a web client. I call it Rover. And if we tell Rover to use HTTPS, it sets up our transport layer so that it uses an extra class called the TLS decorator. Hey there, Rally Monkey. I suppose I should go back to my nice little drawing of this. So Rover is our app. It implements a class that I made called HTTP client. And the bottom, stuff you might be already familiar with, like sockets in Windows or Linux. I wrote a class to abstract away the differences between operating systems. That's called network connection. It's got an interface called network connection. In between network connection and Rover is an adapter called a client transport. It implements this HTTP connection interface, which the web client requires, in terms of network connection. So a couple streams back, I introduced this capability of making secure connections to servers using a decorator called TLS decorator. Decorator, it's a pattern in programming, and usually it's a component that has this kind of design where it takes an object that supports a certain interface and provides exactly the same interface to something else, either by forwarding and doing nothing, that would be like a null decorator, or forwarding some things and adjusting or adding behaviors to other things before forwarding them on, or not even forwarding them on to the thing that's at the lower layer. Anyway, we plugged it in right between our transport and our connection, so that when our client asks to make a connection to a web server, it'll first go through the TLS decorator, and the TLS decorator will do things like start up a transport layer security session, so exchanging keys and all that stuff. And as far as the app knows, it just knows that it's using a TLS decorator, but it doesn't need to know the details of the key exchange and all that. And the underlying network connection doesn't really know whether or not we're using a TLS decorator either. It just is forwarding on the raw bytes to and from the server. So we've been getting away with using this TLS without certificates in the past. And that's because, as I did some research between streams, there were these 2 lines that I took from example code while I was learning how to use this library. And you can kind of figure it out from the name. TLS configure insecure no verify certificate, no verify server name. It's basically telling the TLS library, don't worry about the certificate, don't worry about the name matching. Just, just let it connect even if it's no certificate or bad certificate or not no matching name. So it's kind of a bad thing to do this. It's giving you a secure connection, but not verifying you're talking to who you think you are. So what I found out, here I'll repeat what I did off stream. If we were to comment that stuff out and then run our web client, do Rover, debug, Rover, HTTPS. Where was I going to? Should have bookmarked it. I wanted to kind of right. I was gonna I was going to one of these example pages and just saying I want to see this page in its raw form, and I was taking this link. So if we try that, we get this error: failed to open CA, or is the certificate authority file, and then it's looking for a cert.pem. So I did some research offline, and if you're interested in the details of that, I have it here under supporting certificates in TLS client mode. And I will just run through this. So actually, I didn't see this error at first. It just didn't work. I found it was because I was missing a little bit of code, and I can show you what I had to add in the TLS decorator. I had to add these lines where if the TLS connect callbacks fails, that we actually retrieve the error message and publish it as a diagnostic message. So then I was seeing this error, and I researched what is cert.pem online and found it's by convention OpenSSL and derivatives like LibreSSL, that what I use, is a concatenation of all the root certificate authority certificates that the program should trust. And I found this LibreSSL actually comes with a copy of one. Presumably that's all the trusted CA certificates that the developers of LibreSSL had compiled together, right? I also found a couple other cert.pems, like there was one in the SSH directory for MinGW Git. And it turns out web browsers have their own certificate authority lists. So with LibreSSL, I found that there are basically 3 ways that we can tell LibreSSL how to find the certificates. Use config setCA file, which is to load it from a single PEM file. PEM is the file format for certificates and other things. So if you're not familiar with that, let's load up our PEM file. I think I have in my recent folder here. And I'll load the one from. So it's just a concatenation of base 64 encoded certificates. They all start with begin certificate and they end with end certificate. And what's in the middle is just a base 64 encoding of the certificate in, I think it's x.509 format. But it's exactly the format that our LibreSSL needs. So we don't really have to do much other than tell it about this file, and it'll load all of the certificate authority. If you're not sure how certificate authorities and certificates work, that's sort of a long topic on its own, but I'll boil it down to you. When you go to a web server and it's trying to prove that it's legitimate, it will have made a certificate and gotten one of these certificate authorities to sign it saying it's authentic. It uses cryptographic signatures, which are extremely hard to forge. I think only government level entities can do that kind of thing, and probably not very many governments. But who trusts the certificate authorities are who they are? It's mostly by popularity and by verification. So popular certificate authorities would be like Visa and VeriSign, GoDaddy, other well-known companies. And so whoever puts together cryptographic libraries like LibreSSL kind of collects together all the current certificates, and there are about like 180 or so of them that I found in LibreSSL's cert.pem. And you're basically trusting the certificate authorities just because someone else verified them, or they're popular companies that they're easy to verify, or they've been audited, etc. So those certificate authorities sign individual website certificates. Individual websites then give you the certificate every time you connect with TLS. So by turning off this, we're saying to the TLS library that we do want to verify their certificate and the server name. So if you don't get a certificate, or in this case, we didn't have a certificate files loaded, it's not going to be able to verify the certificate, so it won't be able to run, right? So yeah, back to the ways to load it. So you can load it from a file. I found out you can also load it from a path, in which case it expects each certificate to be in its own file, and then the names are special. So there's a hash code of the certificate as an 8 hex digit code followed by a .0. That has to be the name of the file. And then the contents is just the contents of one certificate. And then the third way I found, which is probably what I'll use, is this setCA mem to load it directly from memory. So this is what you do if you already have the certificate authority certificates already loaded in memory, or you wanted to be in charge of loading it from a file. And yeah, I think I'll do that. Well, what I found, if none of these are called, which is in the case now, it defaults in essence to calling .ca file with a hard-coded path that comes from our CMake list. And so it was going to where it thought I would install Rover and going and expecting etc ssl cert.pem to be there. So it's not there, so it fails. So to get this to work really quick, what I was playing around with, like I say in my notes, if I just call set ca file and pass it a path to a valid file. So TLS config set ca file, and then we have to say impl TLS config.get, and then we pass it the path to us to our file. So just hard code it. So where did I say I found it? Apps open SSL cert.pem. Apps open SSL. Well, thanks, Rally Monkey. Cert.pem. So this should get it past that error, and it should actually work again. Because we're going to a site that has, GitHub obviously has a signed certificate that's trusted. Oh, I must have misspelled something. Huh. Did I not build that? Interesting. Maybe that path is wrong. Projects. Let's see. Did I misspell that? Okay. Okay, it's correct. This was working yesterday. I'm doing something simple wrong, though. It's still trying to go... Okay. What did I do wrong? Project only, rebuild only rover. It's like it didn't actually build the program. Still okay. Let's step through this. It was working yesterday. I'm doing something simple but wrong though. Okay, we need to put that address of the site. This one. There. Okay. Failed to read file. Huh. It can open it, but it can't read it? That's weird. It's like the size is different. I wonder if it has something to do with new lines. This open shouldn't convert new lines, though. Where's the buffer? It's in there. I wonder if what I was playing with yesterday, I was actually using the one from that I was looking at in here in VS Code. This one was program files git min.gw. So let's try that one. How do I copy the path? And then we'll paste it here. And change the backslashes to forward slashes. Try that again. Guessing it's something to do with reading lines that are text and it's expecting them to be terminated by just line feeds. And since they have carriage returns in there, the number of characters read is not the same. Okay, I think that was probably it. So now it's actually working. All right. So now let's see. Let me verify that I got that right. So what I'm going to do is I'm going to put that in the clipboard, back it out. Comment it out, and I'm going to go into that file and actually see if the see the one from min.gw is terminated by line feeds. I bet the problem is the one in LibreSSL's carriage return line feeds. And if I went in there here and yeah, see carriage return line feed. If I turn it to line feed and save it, I wonder if it'll work now. Yeah, I think that's it. So it worked that time, and I bet I can make it break just by undoing that. Yeah. It's interesting it says no such file or directory, though. It's not that it's no such file or directory, it's just reading it wrong. So that's one reason why I didn't want to use the CA file. I think we want to be in charge of reading the file. And we'll use CA mem instead. So problem is we need to get it into the decorator. Test-driven development, right? Even though it's painful. Start by writing a test. Actually, let's just duplicate the last test. This will be configure CA certificates. I'm wondering if we should just make it required, a required argument of configure. Then I don't really need its own test, do I? Well, I actually sort of do. Yeah, let's make it required. So there's lower layer right now. Then we'll have it. Second argument, I guess, will be the certificates. So pretend there are certificates here. Okay. And then we'll just duplicate that everywhere where we have configure. We'll just include that. Because if you remember, we're not going to the real TLS, we're going to a mock, so we can do whatever we want. It doesn't have to actually be valid certificates. I just want to make sure that it gets to the TLS layer. Etc., etc. Okay. So setup, we don't even need to connect. I want to just verify. Well, that's not even setup. Pass in something for CA certificates. And then verify. Actually, what we're doing it in process, right? Yeah, so I do need to bring in the code that calls process, this stuff. Even though we don't need to actually do anything in our delegates. verify the CA certificates were configured. So it's going to be essentially expect that this equals. This is what we expect. Then we're going to ask mock TLS CA certs. Make sure they match, right? Yeah. Time for you to do some errands. All right. See you later. Have fun with your errands. Okay. So we need to define that. Mock TLS. So we can put it anywhere here. How about right here? String. Yes, we are including string. So, oh, we don't have this in the shim interface. We need to add it. So I'll go to the shim. And it's this sets, not CXCA file. I want mem. That's what I want. So we'll copy this prototype and put it in the shim. Shim, where are you? Go to the shim. Here it is. And let's put it here. Virtual equal, do I say equal 0? Oh no, I remember now. I wanted to have default implementations. Where's default implementation? Going to the wrong file. Guess I gotta find it myself. Okay, here it is. So, the default okay. Default is just going to forward it. Just like that. The mock, though, is going to store it. We have to say override here. It will be CA certs is, and here I need to kind of collect together this. So center string. I always forget what are the constructors for string and how the arguments are ordered. So I always need to look it up in my manual. String. Basic string, sure. Okay, constructor. I think it is constructor 4 that I want. Yes, because it can contain nulls, although it's just going to be the contents of a file, so it won't. But we already know the length. So it's pointer and then count. Pointer needs to be const char. CA, and then the length, it's already size t, so it's just len. And then what are we supposed to return? Need to look that up. I had a manual page for this, didn't I? So under, where was it? Blanking right now. Here it is. Then it's load file. I found it here, right? So what does it return? 0 on success. All right, so we can return 0. All right, and then all these other compiler errors are because I am adding an argument to this configure. So let's go add that. Configure. So const standard string CA certs. This, well, how do I say it? this is the contents, not the contents, the concatenation of the CA, the root certificate authority, CA, certificates in PEM format. These are the combination of the root certificates to trust in PEM format. All right. Now that should allow this to compile. We're good there. Just need to implement it here. CA certs, right? So we will call, let's leave this line in there. Actually, let's just leave one of those lines. So we need to go through this shim though. TLS config set CMM. Okay, it wants it to be a pointer to bytes, which is fine. We can tell it it's bytes. So everyone knows a character and a byte are the same. Ha ha ha. Little programmer humor there. It is CA certs dot, can I say dot data? Did I misspell something? Oh, I didn't store it. I'll need to store it. Actually, I can do the conversion when we store it. So I can just simply say CA certs dot data and CA certs dot size. All right, so let's define that. There's a good enough place. Vector unit 8 will end up being the correct type. So we'll just repeat the same documentation here. All right, configure. We need to store those certs. So impl CA certs dot assign. Assign wants a pair of iterators. So what we can do, will this work? Can I just say CA certs dot begin, CA certs dot end, even though the types aren't right? I guess it's fine. Alrighty then. Actually, this won't build because Rover itself isn't passing any CA certificates. So just for now, let's move temporarily. We'll move the hard coding of the name. This name in here. Should we load the certificates every time? So it'd be something like this. So we want a string. I wonder if I should just save myself some trouble. Oh no, it could be, let's leave it as a string. We just have to make it. We have to load it. What am I going to do? Don't really need to use it, but I'm feeling like using my file system abstraction, because I can just say here, system abstractions file, CA certs file, and then I can just put that, oh, I lost it already, this string here, and I can say CA certs file dot open. What happens if it fails? We should have a convention about that, like, if we can't open the certificates we should maybe return null. We just need to make sure that the decorator, not the decorator, the transport does the right thing if it gets a null. Actually, I think the way it works is if the connection is null, it just says, oh, I couldn't make a connection. I'll have to verify that though. So if it's not, we can't open return null. Otherwise, I had a convenience function here called read, where we can just have a, okay, yeah, we need a buffer, and we just leave the other two arguments as defaults, and it reads the buffer in. So make a buffer. C certs buffer. This is where I was thinking ahead before. Maybe it'd be nice to be able to just do that, and then I won't need to convert it to a string. But then I'll have to, in my unit tests, do the opposite. So here, we need to make sure it's of the size of the C certs file.size get size. Yeah. Then read it in. That can fail. So if this is not equal to this dot size, all right, so const C certs buffer dot data converted to a const char star, and then C certs buffer dot size puts it into the string. Oh, the problem is returning null. If we're explicit about the return type, that'll fix it. Yeah, that's my overlay when I have to mute the mic, by the way. I need to replace the overlay so that it doesn't, I don't blame the dog all the time. Now the majority of the time is I'm muting it because I have to say hello or goodbye to somebody. So if I disambiguate the return value here, it should work. It wants a system abstractions I network connection. Now that it's disambiguated, it'll work. All right. So we can run the test first. So that's, what is that? TLS decorator test debug TLS decorator test. So those are working. And now I should be able to go back and run Rover as well. And it's working. I need to make sure though that if this connection factory fails, it'll return a null. Okay, yeah, it's gonna end up calling null, isn't it? We should fix that. So that is in network transport tests. We'll make a little example here. So connection factory returns null pointer. So we'll just have it return null pointer. And then when we try to make a connection, we should expect equal null pointer for the HTTP connection. Instead, it's going to crash right now. We'll fix it. So that's HTTP network transport test. So there, it crashed. So to fix it, it should be as simple as we just check this for null. Actually, we can also print a diagnostic message. Let's do that. And then we can expect that diagnostic message back. Let's see. Format. The level is system instructions diagnostic center levels error. The format is unable to construct connection to, and then we'll just give the address. And then the port number, I suppose. And we take host name or address C string and then port. This is from int types. I'm already including it, so we're good. And then we will need to return null pointer ourselves. And I should check for that here. I don't have any tests that actually look at diagnostic messages. Where's one that does? Ah, here's one. So we can expect it. It'll be client transport. This stuff. Com 1, 2, 3, 4, right? Don't need a printf. We can just do that. Like that, right? Oh, level 10. Yeah, not 1. 10 for error. Cool. So now if I break Rover by just kind of misspelling the name of the file, we should get that message out. Unable to construct connection. There you go. Then we fix it. I wonder if we could get the error all the way out. I guess in order to do that, the connection factory, we would have to be able to pass the connection factory diagnostic publisher or sender. I don't want to go that far. Actually, we could print it here. Set, yeah, well, that's if Rover. Why not? All we need to do is capture that diagnostic message and then I can print it here. So we can say Rover, error. Unable to open root CA certificates file. And here we can say unable to read it. Now we'll see a little bit. Oh, did I unhack it? I need to hack it again. We should see 2 messages now. Unable to open it, and then unable to construct connection. Right. Okay, cool. And we're good. We're good except for right now it's hard coding it. I think what I'll do is I'll just make, what should I do? Make it a command line argument? Or how about we'll just default it to, it'll look for cert.pem in the same folder as the executable. How about that? So, oh, that's right. I wanted to look at how the CMake lists are constructed for LibreSSL to see if this file is somehow exported in a way we can get to it. Let's see, cert.pem. They have a conf dir. Right, so we could set OpenSSL dir to end up installing it in a place of our choosing. But that's only if we run the install step. I don't know. Where did I do a copy step in my own CMake list? That would have been in these, not that. Or was it web servers plugins, right? Make copies at some point? No, maybe it was the web server itself. Oh no, it was the tests for the web server. Yeah, this copy thing here. So what if we just make one of those in Rover? Hmm. It'll only run if Rover is built. But how often are we going to change the certificates file, really? So let's see if I can figure this out. I think what I want is a target property of LibreSSL to get its source path. So I find that target property. Looks like I searched for this before. Yeah, I want this kind of a generator thing. Like this. Not TLS? Not TLS. It's apps. But apps doesn't declare any. Oh, apps OpenSSL doesn't declare any targets, does it? I guess there's OpenSSL, but we're not even building it. Yeah, we're not building the app, so we're not adding the subdirectory, so the target won't exist. I guess we'll just have to kind of cheat and make it relative to something we do build, which is TLS. So it'd be like TLS source dir source absolute path to the source. Okay, and then slash dot dot slash apps OpenSSL cert.pem. Let's try that out. And okay, it did change something. Hopefully what it did was make a post build step in Rover. Build events, post build, or no post build step. Okay. Huh. Did I not do that right? Should have added a post build step. Let me close this and reopen it. Sometimes it doesn't reload correctly. Okay, we'll find out. Yeah, see, it just didn't reload correctly. So looking at this in the editor here, what's it gonna do? C or E Project Excalibur LibreSSL TLS and then back up one apps open it. Okay, that actually looks like it'll work. So then what we can do is construct the name of the PEM file by taking system abstractions. I think it was directory, so I need to include directory. Not directory monitor. Do not call it direct. Maybe it was just file. So file, and then there was get exe parent directory. The directory containing the application's executable image. That's exactly what I want. And then add PEM to that. So it's going to side load the root CA certificates. So let's try that. Hey, it worked. And there it is. So if I were to delete that, oh, let's see, Rover debug. Oops. And then we try to run it. It should say, yeah, unable to open the root CA certificates file. We should probably give the path to it, right? And that means we can say CA certs. Oh, which means I need to make a formatting of a string here. Do I not have string formatting in this file? First time we're doing it, I guess. String extensions. And that. And CA certs file dot get path as a C string. Okay, so it actually, I need to delete it again because every time we build it, it's going to run that post-build step. I can confirm that by looking at it and see, yeah, it's there again. So delete it again and then run it. Okay, so it tells us where the file should have been. And then I have to do a dummy change to force it to build. Don't have to, it's one way to do it. And then we run it again and see that it works. Cool. I think I'm ready to check this stuff in. Okay, so we added the capability to specify certificate authority certificates when we configure our decorator, and then we are shimming the configuration function to set them. Right? We're storing them in configure and then using them here. I guess we can remove that now. We don't really want to do that. We do want to have an option, and we'll run into this later, I think. We will want to have an option to let the user force us to not require a valid certificate, because you want to do that for testing. Like if you have a self-signed certificate and you don't want to have to go through the bother of adding your own self-signed certificate as a root CA certificate and all that jazz. So we'll want to add the capability to override and turn off certificate verification. But right now we'll just require it. Okay. Pretend there's certificates here. Okay. And we just make sure it ends up in the TLS layer. Cool. TLS decorator. Well, we don't have to say this. There's only one class in this library, really, which is named that. So we'll just say add capability of setting trusted root CA certificates. Push that, and then Rover, we'll be updating Rover. Or already updated it. We're going to check it in. So let's do this in 2 steps, I think. No, we can do it together. The first thing being that we make a copy of the CA certificates from LibreSSL every time we build Rover, if it's not there or if it's newer. And then, okay, 2 things here. We're reading in the certificates and then passing them to the TLS decorator, and we're also printing an error, aren't we? I guess that went with the change. Reading the certificates, and if there is an error, we print a diagnostic. Okay, so read in trusted CA. Trusted root CA certificates copied from LibreSSL. Or how about use trusted root CA certificates copied from LibreSSL? That might be it for the client side, and we can move on to the exciting world of servers again. What did I change there? libSSL. Oh, I guess when I saved it in VS Code, it did a bit of cleanup. What about that other file? Oh, really? It's only that one file? So if we want to reset it, we can just check it out. There should be no differences now. Okay. What was the other? There's one other change. Was it in the root? No, it was in... Oh, network. Yeah, that's right. Right. We put in a provision for if the connection factory fails. And a test for it. Okay. So that's in client network transport. A catch when connection factory fails. Alright, so let's go back to the plan. Look where we are. Plan. Okay, done with bullet number 1. I guess we're moving on to bullet number 2. Enable the decorator for servers. So, 2 things we'll need to do. Very broad things, which will involve other things as well. Number 1 is we don't call TLS client, we call TLS server. And the second thing is we need to provide 2 things to TLS, a certificate and a private key. Certificate we just talked about a bit ago. That's how the server proves that it is who it says it is. The private key is used in the actual verification process, I believe. Because anyway, if you get the server certificate, if you didn't have some way of proving that you own that certificate, which is what the private key is, then since this is public, you could use it anywhere and forge your identity, right? So to prove your identity, it's actually 2 things required: the certificate, which is like the public key, the public part, and the private, which is used to prove that you're the owner of the certificate, since you're the only one who has it. So we'll have to configure our server with both. It sends a certificate as is, and then during the handshake with clients, it'll be using the private key to prove that it's the owner of the certificate. I think this third bullet is really part 3 of this one, because we'll have the same problem we had with the client, where right now this server network transport is sort of hard-coded to use network connection. We'll have to enable it to use a decorator. Or really a factory, right? Our factory for using TLS will create one of these decorators. So one thing at a time. Let's enable server mode. So test-driven development means we write this test first. Okay, so let's change this. Start with that, but then we'll change it. So it'll be start TLS as server. Oh, how about start TLS server mode? I think the distinction will be connect will be if it's a client, and we'll need an alternative if it's a server. So, what should we name it? Let me look and see where this connect was part of the interface, right? Yeah, iNetwork connection. There's no real equivalent for server because the way my network connection class works as a server is another class called network endpoint creates a network connection every time a new connection from a client comes in. So in essence, you don't need to connect because it comes in already connected. We'll just make an alternative outside of the interface let's call it. Actually, how about we'll change this a little bit. So this will be configure as client, and then we'll make alternative. We'll probably have an internal common part. Maybe, I'm not sure. Actually, these configures were pretty straightforward, right? So so this shouldn't be that big a deal. So the first one, client mode, yeah. So I think I was already thinking about this before, that I want to have an alternative for server mode, connect or receiving a connection from a client. And this is over 80 characters. So let's wrap it. Question, do we still need the root CA certificates? I think we do not, unless we require the client to have a certificate. I think maybe we don't need to do that for server. But instead, we'll need to have our own certificate. This is the server's certificate in PEM format. And then we'll have key. This is the server's private key. And I need to check again. What is the format of a private key? Is it PEM? I don't know. Let's ask Google. What format is a private key in? Actually, if we had a PFX, it could be together. It's a little bit too technical. I just want to know, is it PEM? What is PEM? Okay, what? Maybe this is the one I want to see. I guess it is PEM. PEM is base 64 format, right? Right, no naming convention, so they could end in different things. Well, let's make a private key pair, or certificate and private key, and that's easy to find. Open SSL, make self-signed certificate. Stack Overflow is our friend. This is exactly what I want. Let's do that. That way I can make one and not have to hide it from you guys, because I'm only going to use it locally. Just to play around with it. So rsay 496. And if you can follow along at home if you want to make your own self-signed certificate. PEM passphrase. How about password? Country name, US, state, province. I don't know. What state do we want to say? Make up our own state. I wish I was in Hawaii, so I'll say Hawaii. Locality name, city. I guess we don't really need one. Organization. Internet widgets party. That's a funny default. What do I want to say? Acme. Unit name, no unit name. Common name. So this is the important part. We want this to match something. So how about example.com? Email address, no email address. Okay. So what did it actually make? So it made a cert and a key. So they are both PEM. If we were to look that in VS Code. So they're both PEM, but the only difference is the cert is begin certificate. The key is encrypted private key. But they're both base 64 blobs of bytes, essentially. Let's take this link and put it in my notes. I remember where I went. This is the Stack Overflow page that gave me the command for creating a self-signed certificate and key. And this is the command itself for the impatient, which I often am. The command itself, whoops, is this, oh wait a minute, paste, keep text only, there we go. All right. Okay, so they'll both be in PEM format, and I believe we don't have a server name because it's all built into the cert. So it'll be just cert and key. Okay, everywhere we used to call it configure, we're gonna have to fix it to say configure as client. Decorator.configure becomes decorator.configure as client. Except for this one. This one will be server. So pretend this is a certificate, okay? And then pretend this is a private key. Okay. So we don't need to call connect. We're not going to check that it's connected. We're not going to do this. Oh, I do need to call process, right? Right, so then we will verify the process was called. How about we'll copy from here? Still have that. I wonder if we need to set the protocol. I was going to look into that. Right now we're setting the protocol to default, but I think if we don't set it, it just is the default. Right. Here's where I'm not sure if we'll call TLS connect or not. I need to verify. I think we still do, because we have to give it callbacks. We'll expect all of these three things. I think then we'll expect a fourth thing. This is not, well, okay. Yeah, okay, fine. I'm gonna expect a fourth thing in that TLS client server mode. And let's modify the old one. We just need to have one of these tests do the opposite. We'll expect false that it's server mode. And then we'll have to have this flag. Cool. TLS server mode. Okay, yeah, we need to include in the shim our TLS server. We have TLS client, we need TLS server as well. I'm just looking to see where is it declared. Oh, I'm not seeing it. Yeah, where is it declared? There it's declared. Oh, so I could have just copied it from client and just renamed it. TLS client, oh, that was in shim, wasn't it? Shim HTTP. TLS client, so TLS server. And then the shim's default. We'll just copy paste it. How about that? TLS server. That way, in our tests, we can set that flag accordingly. So we will say TLS server mode false, although it's already false. And here we'll say it's true. And that's server, isn't it? Okay. And I need to update Rover, right? Because it still says configure. We need to say configure as client, just to get it to compile. Okay, missed something. What did I miss? Ah, as client. And I'm missing the implementation of the configure as server, now that I think about it. And we can just have it empty for now, just to get it to build. One step at a time, right? Configure as server, fine. Alright, so what was this other impl declared? Oh, because the name of the method changed. Cool. So, we'll test it. It will fail. TLS decorator test debug. So, yeah, it just completely crashes. And we call set server mode. I'm actually curious why it crashed. It should have just done nothing. Oh, probably because process, the real process in the decorator expects stuff to be set up. Yeah, probably. So I guess it's expected for it to crash. So we need to actually do the right thing. Actually, where do we join the worker? We join it in close. So theoretically, we could take a decorator, use it as a client, and then close it, and then reopen it as a server, right? So that means, for one thing, I'm going to have a flag, right? Mode, and we'll make it mode client. And then instead of just having a boolean, we'll have mode server. Let's see, I guess we want the same kinds of things here. Cert equals cert. Key equals key. And we'll put that in near CA certs is probably a good place. Yeah, do we want it to be a vector? I guess we do. Load it the same way we loaded the CA certs. So cert and then key. This is pro copy pasta. You've seen it. It's all pro. Okay, this is this and this is that. I need the mode thing though. Actually, I'm going to declare it here. That makes sense? I think it does. These are the different modes the decorator can be in. enum class mode. Okay. In this mode, the decorator is operating the TLS layer in client mode as a client. As a client. Client. In this mode, the decorator is operating the TLS client layer as a server. And let's introduce none. In this mode, the decorator is not yet configured. We will use that as a convenient way of checking to make sure we don't call configure when it's already called, and that we don't call it twice, or we don't call process until we call configure, and we don't allow process to be called twice. So we need to store that. Store it anywhere around here. I kind of feel like putting it here. This is the current mode. Okay, this indicates the current mode of the decorator. It's a pretty lame comment, but mode is mode. And then I can say none. And then let's make some tests here. Some really stupid tests. So we'll say process without configure. And I had something which generated messages, right? Yeah. This thingy. So okay, so what I want to do for this kind of test is I just try to call process, and it should say, well, you haven't configured it yet. So I should get a level 10 message saying decorator process called before without first configuring. Right, and then furthermore we can expect false from that. Okay, and the other thing I wanted to check was if we configure it, if we configure it and then we try to call process a second time. So this will be process when already processing. All right, so we configure it as a server, and then we try to configure it as a server again, I guess. Or no, we could try to call process again. We will, actually already have that code in there, expect false, and we'll say process called while already processing. Okay, so let's put both of those in. Okay, this needs to be impl, I believe. And then here, and then I need to do the same thing I did with this assign, right? Cert begin and end. Key assigned key begin end. Alrighty. So in the process, we want to say if impl mode is not equal to impl mode none, then where's an example error? Here's an example error. We don't need to format it though. We can simply make it a string. We can say process called, what did I say in the test? While already processing. Actually, this is the wrong message, isn't it? There are two checks I need. while already processing would be if this worker is joinable. So if I don't have a check for that already. It should say, yeah, it's up here in configure, actually. If the worker's already running, then we're already processing. If it's not none, actually, well, if it is none, it would be process call without first configuring. Okay. Didn't quite finish the server stuff, so this is still going to fail, but I wanted to check, okay, a process when already processing is crashing. It shouldn't. So let's fix that. Actually, I believe it's crashing because the other one's crashing. Actually, it's not crashing, but it's not going into server mode, is it? Well, anyway, let's finish the coding for configuring it as a server. Actually, that shouldn't have crashed. So what's going on? Let's see. Set up TLS decorator test to be the one we run, and then run it. Okay, we are, what, printing something? What's its error? Can't increment the vector. Oh, hold on. Is that because the worker thread is writing? That's not the worker thread. That's the worker thread. Okay, yeah, the worker thread is trying to write something. What's it trying to write? TLS want pull in. Oh, there are more diagnostic messages. TLS read process call while already processing. Okay, yeah. Let's avoid this issue. It's racing other errors being generated. I'm going to avoid that issue by using a separate diagnostic message subscriber up here, and which I use a default level of 10. So I only want level 10 messages. And then I just look at this instead of the other one. Okay, cool. So it's just not putting it into server mode. So let's do that now. The difference will be when we actually call TLS client here. So it'll be this. If impl mode is mode client, we can do that. Otherwise, we're going to make it a server. A little bit of copy pasta here, and I'm wondering, this delegate we can make outside and then just pass it in, right? So let's make that outside. Const auto TLS impl deleter. I think that's, or what's it called? Deleter is probably fine. Is it deleter or deletor? I don't remember. We can just say that. And then we can just pass that in both places. And then that's server. Right? Actually, we're going to move this into the client thing. We're only setting certificate authority certificates if it's a client. And then if it's a server, we do a little bit more, right? Well, this will pass our test for now, but there are additional requirements that we're not checking. So it's passing now, but let's put in the additional requirements. And that's similar to the CA thing. We want to make sure that the key and such are configured. Okay, so setup. Is this the right test? This is not the right test. Glad I checked before I got too far. This is the right test. So setup. Configure decorator as a server. Verify the certificates. Verify the certificate and key were configured. So this should show up there for cert, and then the key should show up for key. We just need to store them. So cert and key. Okay, so that is not in our shim yet, so we need to add that. But here we can find it. It's TLS configure set. Okay, maybe not this header. Okay, where would it be? Let's look for where that's declared. It's probably no, not that one. Like, where is it? Like this one. Where is that declared? There we go. So I want this one in my shim. And I want the key one as well. Actually, I want the... Raises an interesting problem. Key file doesn't let me set the password, but key pair file... Oh, that doesn't either. Where do I actually set the password? Am I supposed to decrypt it myself? Oh, maybe it was... No, that's certificate length, key length. Where do I set the password? TLS load file. Ah, yeah. So we're gonna want to do that one. Because I don't want to mess with how do we decrypt it. It'll deviate a little bit from... Actually, no, that's not gonna work, will it? Is this the only way I can decrypt it? Is by telling it where it is as a file? Okay, actually, you know, I need to take a minute break. So, apologies for the abrupt break, but I'll be back in just a minute or two. Be right back. Hey, I'm back. Yeah, I made a password protected key file, and it looks like the only TLS API function that takes a password is load file, but that requires me to tell it where it is in my file system. I'd rather not have the decorator deal directly with files. So let's see what this actually calls. Maybe I can do the same thing. I need a better timeout screen, huh? Yeah, probably. That timeout screen is pretty noob, isn't it? Load the file. Let's see what it does. Pem read private key. What does that do? Huh. It's a bit elaborate. Is there a way I can do this without this part? No, it's actually reading. Let's see if something else calls this. Yeah, I'll take a file. Well, so does this, but maybe it's this that I want to search for. Hmm. I'm looking for a way we can call this on a memory buffer and not a file. I think we want to call this with just a different, I think this is byte IO interface. That takes it from a file. This null key. Oh, it's from a file. Okay. Never mind. File internal. Oh, I think this is what I want. Okay. Where do we, how do we get the password in? There's a password callback. Really? What's the password callback? Oh, I guess it's an internal interface. Yeah, it's TLS internal.h. Okay. Yeah, how is the password given? I guess we had this example here where you just pass the password there, and I could combine it with this where we use a VIO from a memory buffer. It's just too bad that there's no code that does this already for us. We'd have to, can we use bio.h? Where is that? That's in OpenSSL. Where are we already depending on that? That would be in our TLS decorator CMake. SSL. Is that the same library? Let me check. That'd be libSSL, SSL, CMake, and see where does it put its headers. Oh, I guess. Guess it's there. Okay, more importantly would be, where is this actually defined? It's in BSS mem. BSS mem. Let's search for that. BSS mem.c. Where I want to see what library it's in. Okay, how do I say files to include? Cmake lists.txt. It's in crypto. Oh, okay. Well, we're depending on crypto. No, not there. Crypto. So we're including crypto. Yeah, we can make this work. We'll have to do what they do though. So a combination. So we'll call this. We have to remember to call that when we're done with it. We'll pass in the raw password there. And instead of doing bio new file, we'll try bio new membuff. Right. And we just have to remember at the end of this probably does bio free. Okay, so let's do this. So this one was easy. The key is more difficult. Okay, what was the first method we needed? Bio new membuff, right? Add. Oh, how come? That was weird. Did I accidentally edit that? No, it's just my eyes tricking me. We need bio. Where do we put that? At the beginning, maybe? And this is in bio.h from OpenSSL. All right. And what's next? This one. This is in OpenSSL pem.h. Ooh. It's declared using a macro. I hate it when they do that. Pem read bio private key. Macros within macros. I hate it. Okay, so it's going to unroll to what? Whatever type is. Just passed all the way through. So it's this thing. And then I guess we're gluing private key as is glued as the name. And then that type again. Oh, we wanted null for that, right? Hold on. Still need the type though. This type. Okay, OpenSSL pem.h, right? So OpenSSL pem.h. Okay, so there's the unrolled prototype. And what else? Need a bio free in the shim. That probably should go there, right? Oh, there's a tab in there. Tricky tab. Get out of there, tab. Okay, what else? There was one other thing, right? It was like there was one to destroy the key when we were done. EVP P key free. I love it. I love the name. Virtual. So as that fourth argument can be a raw password, it looks like. Go definitions, verify that. If that U is not null, right? It's several layers down, looks like. Default PEM default callback. Last argument to that is the key, I guess that's the password. Oh wow. You can actually have it prompt you. Need to see what do we do if there is no password? Where was that done? Up here somewhere? I suppose if there's no passwords, actually I should have just gone into where that U is used. I suppose if it's null or something, then it skips it, right? Many layers deep. See, screw the documentation, we're just reading their code. U. Callback is null. What does this do when key is null? Ah. Oh, it does a prompt. Okay, but what if it's not null, but it's empty? Then it'll be 0. It'll just return 0. Looks like it. I guess that's what we want. So there'll always be a password, non-null, but it could be empty. Let's try it out. So we'll have to try this with 2 different keys. I made one with a passphrase. Maybe I should make another one without a passphrase. So where did I put it? One directory up. Yeah, so let me make one a test cert key with password and make one without. I'm in a normal shell, so I can do a dir, not an ls, and a move to this one. And then test cert key, no password. See if I can go to the history and get that command back. Nope. Maybe it's in there somewhere, I just can't see it. Maybe I did it from the other command prompt. I did, look at that. So there was a way, what, if I just hit enter, right? You must type in characters. Okay, so there's got to be a way to have it no password. Oh, nodes. If you don't want to protect your key with a password. Okay, nodes. All right. I have to try to remember what I put in here. I think it was US, Hawaii, because I want to be in Hawaii right now. And it was Acme. Common name was example.com, I think. Let's scroll up and see. Yeah. Yeah, and then no email address. I'm not really in Hawaii. I'm just being a troll or a kappa or whatever you want to say. Just playing around because this doesn't have to be a real certificate. I can say what I want. And I want to say where I want to be and not where I am. Okay, okay, so now I have 2 keys. No password and with password, so we can play around with both when we're testing. And we have everything in the shim that we need. We're going to call that and then use that bio with that. And then free it with that and then free the bio with that. But okay, where is that? How does that actually, how is that used? It's this EVP peak key. Oh, you know, maybe we're loading too. Maybe this is the wrong way to go. Okay, because we need to be giving it to TLS. I need to get it in here somewhere. I guess we can call that directly. SSL CTXUs, but I have to reach into the SSL context. Let me make sure this is the only place it's actually called. Oh, no, there's called in a couple different places. No, TLS is the only place it's called. Is this configure SSL key pair? Wait a minute. So what happens? What happens when I call TLS configure? What was it? I forget what I called it. Oh, it's config. TLS config set. What is it? Set something. Let's go here. No, go to the shim. And then from here, say go to definition. Right, TLS config set key. Yeah, the set key mem. What does it do? Oh, I see. It's putting in this config key pair thing. So where is that used? Hmm. So the one that used the password, that wasn't even in here? Shoot, where was it then? Right, TLS load file. Oh, that's right. We have to also call, when we're done, the set key mem. We needed that in our shim also. That's cert mem, key mem. The question is, how do we get the actual key out of this? And I was going to look at, see what they do. It was load file, wasn't it? TLS load file. Bio get mem data. That's what they do. And then they copy it to buff. Buff is what they return, right? Yeah. Okay, so we just need to do the same thing. Bio get mem data. Oh, great, it's a macro. I hate macros. Okay, so this is the function. Wait. This is sort of the function we need. Shim. Put it between the new and the free. It's not biocontrol per se. I already lost my place. Ugh, I lost my place. I would just go back a bunch of times. Maybe I'll get back. Oh yeah, there we go. This one. So this is just with a typecast and some extra stuff inserted. Actually, do we just want to have that forwarded, right? Let me think about that. Yeah, because we'll use it like they use it. So we'll have it be in the shim. So we'll just keep it as control then. Right. All right. So we need to actually put this into the real shim. Here, 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 and here. And these all forward. Everything as is. BP command larg parg return bio new mem buff lane rit run. Okay, and then there are these two guys. There's this guy here. And return the global config cert len. Set key mem key len. Okay. There's going to be a pain in the behind to mock this stuff. Okay. How to mock these? Actually, you know, it would be faster just to copy from the header. And then all we need to say is override. Like that. Whoops. I suppose someday I should improve the tools I use to actually automate more of what I'm typing. See, a mem. Actually, the mocking might not be that bad. Override and override. So we're going to want to do the same thing for the certificate and the key. It's just going to be key and cert. And this is this, and this is that. And okay, I think we can just kind of skip all this stuff. We can be a little bit sneaky about it. Well, actually, let me think about this. We don't really need to do anything here. This doesn't need to do anything. What was that again? Right, that's get mem data. This one does need to return something, doesn't it? Because we're going to be using that to copy stuff. Not there. I think it was there. We're going to essentially do the same thing they do. This is, yeah, it needs the actual, because we're going to do the same mem copy. It's got to actually get the so-called decrypted key out at that point. So we can kind of fake it, right? It's a pointer to a pointer, I believe. PP, pointer to pointer. Yeah, it's already a pointer, so yeah, so not the real one. In the test. This is the one where it's only going to get called to basically do this, right? So it'd be void pointer, the address of private key or decrypted key. I did not like that. Anyway, this we just need to make. Let's actually turn that into a C string, and then next to key, we'll have decrypted key. And this will be encrypted key. And then we'll have key password. German still doesn't like that. Complete object type. Okay, fine. Well, we'll just turn it around here. So it'll be pretend it's a char pointer and then store into it. Const char pointer. L value, L value. Ew. Yeah. Maybe that was the problem all along. That's actually what we want anyway, right? It's going to be a double pointer, and we're going to store the pointer to the string in there. Right. I don't think we actually need to do anything for this stuff, though. Okay, so this is going to be encrypted key. No, decrypted key, right? Oh, hold on, wait a minute. This is the key that's given back to TLS. This is sort of an intermediate one. Yeah, so I do want to do a few things here. Where, yeah, go back to the example where that's done. Yeah. But I wanted the one that deals with memory. Yeah, this one. So yeah, its last parameter is the password. So I wanted to actually store that in our tests. Yeah, so here we go. So key password is, and then we're gonna convert that to a const char pointer. So that we're storing what password was used so we can check it. In fact, we can put that down here. Yeah, let's expect a password. Excellent password. Okay, and then we can actually expect that at the end. So, oh, wait a minute, I put it in the wrong place. I need it in both places anyway. Everywhere where configure as server is called, we'll need it. Right, so here, we'll expect equal excellent password for mock TLS dot key password. That's down here. That decrypted key. How do we check that? I think I'm going to expect it to be given to this guy, right? Oh no, not that one. It wasn't here. I think it was with that. No. Oh, actually, this is the encrypted. Before we call it, we got to tell mock TLS what we want. So mock TLS.decrypted key will be, pretend this is, oh, I'm doing this the wrong test again. It's up here. A decrypted. We'll put in both places actually. So there. And up here. Encrypted. So expect that to show up in decrypted key. No, encrypted key. We still need key. Yes. That's the key configured. Let's say configured key. Configured cert. And that was up in here, right? I wanted to, when it's actually given here, to store it. And then where we extract the encoded and decoded, it's here somewhere, but I'm not exactly, I have to kind of look and see how we're going to do that. What we expect to be done. Yeah, that's definitely the key password. So where the encrypted and, oh no, we set the decrypted key. And we return it there, so we're just missing the encrypted key part. Okay, where was that? Was it inside here? Yeah, it was reading the bytes, right? Well, that reads it decrypted. Maybe this line here is wrong. I think it's here actually. Yeah, this buff and len. Yeah, okay, got it. I got it. I got it. I got it. I got it. So when we make this memory buffer, this is the encrypted key. And then it's expected to call this to like read it out. Yeah, to read out the decrypted key. I hope I got this right. I feel sort of maybe 75% sure I got that right. Okay, what's not... Oh, yeah, so configure for the decorator needs a password. And figure S. So const password. This is the password for the server's private key. Okay, so there, and we're going to want to store it. Actually, I'm just going to store it as is. As a string. All right. That should build. Oh, must return a value. What should we return? Ooh, what does it expect to return? I think it's supposed to return something that's passed into this guy, which we don't use anyway, so we can return 0. Is that right? Oh no, it's the control. The control was... Back from errands. Can I do repeat everything? You'll have to look at the video. Erg. Oh yeah, it wasn't that example, was it? It was... one of these other guys. Oh yeah. So yeah, it was load file. I remember now. It was TLS load file. Oh, where was that? To get the actual thing out of it. It's a size. Okay, so we want the size. Right, because it's going to write into it. Okay. We want the size of the decrypted key. So return decrypted key size as a long. Right, because we were copying it out. It's reading it out that this is called on. And yeah, okay. Yeah, all right. So let's test that. It's going to fail the test. We'll make it pass. Oh, go to the build directory. There we go. Run the TLS decorator tests. Right, so it's not actually doing the setting of the certificate or the key. That's what we need to have it do. And here's maybe the hard part. That was spurious, wasn't it? Okay. It was in this process, right, for a server. So we make the server, and then we're going to want to TLS config set cert mem impl TLS config.get impl cert.data impl cert.size. Okay, that'll fix their certificate one. So now we just haven't done the stuff to do the key. So the key I was going to cobble together from the example code I was seeing, right? It was I think I was seeing it. Yeah, this is how you make a bio. You make a bio and then you call not this function, but the one we shimmed. Read bio private key, right? So we'll make a new one from the encrypted key, call this read to basically read it with the password, which is in U, and then bio control to get the decrypted key out. So let's see if I get this right. So it's first bio new membuff. So const auto bio equals bio new membuff, and then the buffer, which is key data and key dot size, and then this read, right? So const auto key key equals read the key from the bio. I believe we can do null, null, and then the password C string. It didn't like that. Oh, it doesn't like it to be a void. We'll make it void. All right. And then it should read it out. Hold on. How do we get it back out from there? One of these guys. No, oh, I keep forgetting it's TLS load file. And I keep forgetting where that is. Where is that? It's in TLS util. Oh, we have to call read and write. Okay. I forgot. I didn't realize that. So we have the write shimmed, but not the read. No, we have the read shim, but not the write. So it's read encrypted, write decrypted. Wait a minute. Can I just copy that into the shim here? I didn't copy from the header, I copied from the implementation, but I think it'll still work. And shim default implementation should just forward it. Okay, and then our unit test will do something different. Okay. Interesting. So what does it return? It returns what? Whatever this returns. Probably size. I guess I could look it up. Ugh. No comments, must look up. So a 0 is an error and what anything else is success? Come on, people. Document your code better. It doesn't say what it returns. Oh, 1 for success. I love it. 1. We will return 1. But this is actually where the decrypted key should be copied, right? Oh, no. This writes to a bio and this reads it back out. Actually, does this actually copy it, or is it just get a pointer and you can copy from it? Actually, we're going to call that twice, aren't we? Oh no, 1 is it's initialized, so this new is it's encrypted, and then we need to shim the other one too, don't we? Bio new. To shim that one as well. Tab, go away, tab. Okay. Before long, I'll have the entire API shimmed from TLS. Return bio new type. And then what will our test do? This is creating where the decrypted key will be. I think we don't need to do anything. It'll just end up coming out here for the BP, which we don't even use. Right, so new one, we put the encrypted key in. We read it into the key, and then we're going to make another one. This is really encrypted in key input, and then we make another one. Decrypted key output, and that's bio new. Oh, we actually have to go through the shim, I mean, for all of these guys. And then the type, whatever TSUtil did. I'm not gonna shim that one. What does that actually do? Return a constant of some kind? Or it's returning a function table, which I don't use in the unit test, so I'm not gonna bother to shim it. Okay, and then whatever TLS util does, it writes it, and it can fail. So if not write the key, then what do? I guess we're going to print an error. And it can actually have an error message, right? I don't know, does it actually put an error message anywhere? I don't know. Error. I don't think it does. So I think we just have to come up with our own thing. I have to be careful here because every time we make one, we're going to want to delete it, and here we want to delete it early. String actually it's, we'll just say error decrypting private key. All right, now what are the arguments it needs? It needs what we're writing to, so that's decrypted key output, and then the key, and then cipher. I don't know what to put there. Oh, null. Null, null, 0, null, null. Oh, except for that, that's where the password goes in, isn't it? So this is void pointer. Key is it password? Impl password? C string? I think that's what, and I verified that by looking where else it was used, right? And it was somewhere, it was here, I think, one of these guys. Yeah, it was digging down into to see what this U was, and it came from somewhere. The right private key. It was the one that had the password in it. I don't want PAM. I want TLS.h. What's a shoot? Yeah. Declaration of that. Okay, now look for password. Yeah, it was oh wait a minute. There was TLS load file. Oh, the password's okay, I messed up. The password's given when you read, not when you write. And I already did get the password. So when you write it, there's no password. Got it. That can fail? Looks like it can fail, so I need to check that. So if key is null, then what? Error reading? Error reading? Private key, I guess? I could do the errors like they do. Free all. Why is it? Is the free all the one I shimmed? Not free? I shimmed the wrong one. Huh. Okay, well we can fix that. It's free all. I wonder what the difference is between free and free all. Okay, it didn't like that. Oh, void. Okay. Sorry about that. Okay. Yeah, I was answering some questions in the background. Right, I need to remember to free these. Actually, let's do what I was doing in other instances. This thingy, right? Make one of these. Yes. So, how do we do this? Like this, I guess? It's a bio, so bio. Encrypted. And then a deleter. And that is selected shim bio free all p. Right. And we need to do the same thing with the key, don't we? And that type is EVP P key. EVP P key. And the equivalent of that is what? EVP P key free. Alrighty. What happened here? Oh, it needs a get. It just needs a get there. And we're going to have the same No, not the same thing. This thing. Well, this thing for the decrypted key input output is that with the same deleter. Oh, I forgot the shim thing on the other line. Gotta make sure we go through the shim for all this stuff. Alright, so it's .get. Actually, it's .get in both places. So now we don't need to worry about deleting or closing them. What do they call them? Free. Or, yeah, we don't need to worry about freeing the keys of the BIOS. So this gets it. Now the last step was to extract it, I think. Right, this bio get mem data, and we get the size out, and we get a pointer to char. Okay, so char decrypted key contents, and then we call this, right? So const auto decrypted key size is selected shim, and then decrypted key output dot get, and then pointer to pointer. So decrypted key contents. All right, and then we check. If this is less than 0, then what? It's just another error, right? How about it would be error extracting decrypted. Okay, now we have it. We just do a mem copy. So essentially, it's storing it. No, we want to call, we want to actually just give it, right? Yeah, we just give it to key mem, I believe. And then the key is the decrypted key contents, and then the decrypted key size. Okay, interestingly, it's a char, and then what they mem copy it to uint8, so I just, well, does this need a char? What does this actually, does this actually turn into? This is void. It could be anything. So I could use the, oh no, it's typecast so explicitly in the macro. Well, shoot. I hate it when they do that. So that means I have to typecast it. I have to typecast it here. I suppose we can make it const, right? At least do that. Okay, that actually returns something. Do we need to check? What does that actually return? I guess it can fail if it can't copy. If it can't make a copy of the memory, it's not gonna. That never happens. Never run out of memory these days. In fact, I can just explicitly say we don't care what the return value. It's always gonna succeed, and that's probably the same thing I want to do for setting the certificate as well, right? And even in the client where we set the authority, well, hold on, this might be different. This could actually parse wrong, right? Oh, no, it doesn't even check it yet. So again, we don't care. It's just making a copy. All right. That was very elaborate. Let's see if it actually works. Size type mismatch. Oh, they really wanted int? Okay, how quaint. Usually size is size t. Must be an ancient API. Oh, that was free all, wasn't it? And that was now void, so it doesn't need to return anything. All right. So all I can really test is with a mock. With the real thing, I don't have it integrated with our server yet, so we can't really test it. But interesting. So it didn't get it got an error reading private key, really. I guess we're not doing the right thing. Oh, I guess we can't return null pointer? Gotta return something? Okay, what are we gonna return then? I guess we could make a dummy one. Static dummy. Return the address of the dummy. Just a mock anyway. Oh, great, it passed. So if this logic is correct, if the mock is correct, then where was the mock? If I understood how this mock is supposed to work, where when our decorator calls this, it's setting the encrypted key, and when it's calling this, it's extracting the decrypted key. And the read is where the password is given. If I understood all that correctly, then we just successfully tested that the decorator should do the right thing to set up the certificate in the key. So unfortunately, to do this for real, I need to actually have a web server that uses the decorator. I don't have that yet. But we can check in what we have for now and then work on that. Although I try to end by 3 p.m. Pacific, and that's 26 minutes away, so I don't know if I'll actually get to it. Let's check in stuff. Okay, TLS decorator. Configure as client, yes. Let's check those things in separately. So first these. Which one was that? The shim, okay, yeah. I just wanted to check in this rename separately. Right. So all of these hunks where we change the name of configure to configure as client we want. Stage those hunks. Alright, see if I got them all and nothing else. Configure as client, okay. Yep, so rename configure to configure as client. Next, we introduce the server stuff. Let's check in the shim first. This hunk, right? Actually, it's going to need a bunch of stuff. Oh, these aren't pure virtual though. So if we don't add them to the unit test in this check-in, it's fine. Yeah, so we'll just say TLS shim, add more TLS, add more of the TLS. Actually, it's more than just TLS now. And friends API to the shim. Okay, and then we added mocks. We added a test for setting server mode, process without configure, process when already processing. I think I'll just check them all in together. Okay, so TLS decorator. Add server mode. Yeah. I think as far as the decorator is concerned, we're done. We just need to integrate it into the server, which is going to be a couple step process. Okay, Rover probably only changed because of that name change. The TLS decorator configured was renamed to configure as client. And there's some changes in the root directory. I think those are just the keys I made. Yeah. I'm going to leave those untracked for now. Okay, so whoops. Accidentally muted there. Right, so I got through these 2/3 of the enabling the decorator for servers. This last one's going to take a little bit of time. I don't think I have enough time to get through it today, so I'm inclined to do this on Tuesday. Yeah, I wanted to talk a little bit about some upcoming stuff, so need some time for that. So we'll postpone the work for that. So this server network transport, it's like the client one. Like if I go back to this diagram, if you just think of this being the server instead of the client, then there's an equivalent class called HTTP server transport. And it's sort of like the flipping it around, like instead of making a new connection by connecting, you're receiving a new connection from the client. And once you get the connection, it's decorated the same way, only we'll have to configure the decorator to be server mode. So most of it, the work on Tuesday will be to go into HTTP server transport and do the additional steps to allow you to insert a decorator through a factory function. And then we'll have to go into our server and allow the server to be configured. Actually, no. The server probably should look at the scheme. No, it should probably be, it should, whether it's listening on a secure port or not, right? It should pick a factory that either inserts a decorator or doesn't. So yeah, that'll be a little bit of work to figure out the right clean way to do that. So we'll do that Tuesday. I'm not streaming Monday because going to some family stuff. Right, these notes I took today. So we'll get to that Tuesday. And then the other thing I wanted to show was I'm beginning to do research on how do you write a Twitch bot. So it's going to be a little bit of a deviation. If I look back at the log so far, from the very first stream down to, I think it was stream 47, we did web server stuff. Then from stream 48 until now, so about 10 streams, we did client stuff. And no, client stuff was about the first half of those, the last 10 streams. And then the other half was the security stuff. Well, now I'm going to look into the TwitchBot stuff. There are a couple things I need to research and that I'll start showing the code for on stream. And that's, there is a protocol for getting authentication tokens. I don't know if I'll need to do this right away. What I've read so far is you can just get a token manually and then just use the token in your bot. So I might just skip OAuth for at first. But a real bot or extension to Twitch would do the real thing it would do is obtain a token automatically after getting your consent, right? When you enable an extension, give it permission, it's taking your authorization to go get itself a token. And it will use web stuff for that. I believe it uses web API calls in order to retrieve a token, to reserve and retrieve a token. But what I want to focus on first is I looked at how the architecture of Twitch chat, and it's based off of now it's 30 years old, believe it or not, the Internet Relay Chat specification set. And it's a pretty loose collection because it's so old. But IRC, Internet Relay Chat, there's a guide on Twitch. I started there, and it referred to the official RFC for it. I haven't yet read through it, but it turns out the IRC architecture is pretty basic and simple. And I even found, there's lots of examples you can find. I found a nice example about how to make a bot, to talk to Twitch IRC server via WebSockets, which we wrote way back in Stream 20 or so. So one route we can take is simply make a bot that uses WebSockets. And then we don't have to actually implement the real IRC. Although it might be fun to implement IRC itself, because then we could talk not just to Twitch, but any kind of IRC server. So I got to decide whether I want to go the IRC old school route or just talk to Twitch with a WebSocket. But either way, I'll be building up a Twitch bot. I think the first thing I want to do with the bot is pull in the math bot and have it chat in my channel. And then I might do something fun like establish a persistent point tally, so that you will be able to earn points just by answering the math questions correctly. And I don't know what we'll do with the points, but to figure that out. But yeah, that's what I wanted to spend a little bit of time talking about that. So if you're interested in talking to Twitch through IRC or through WebSockets, I'll probably be working on that next week. And yeah, the link to this notebook, by the way, is below. And I tried to, for the stuff I need to learn to do on stream, I try to take all my notes in this notebook. And in addition to what I've already researched, I kind of have listed here what I want to research in the future that I haven't gotten to. And when I feel like I know enough, I'll check it off the list. And then there should be a one-to-one between these pages and then these check marks, at least the ones that I've finished. All right, so that'll pretty much wrap it up for today. That was stream 57. Let's see if we can go host. All right, I think I'm just going to go host Adam again. He's sort of my standby. Great guy working on a JavaScript game where you can program bots to fight each other. So, segue, we were talking about Twitch bots just now, and now we're going to be talking about a game that you program bots. So thank you very much for watching, and I hope to see you next time.